Welcome to myprojectbazaar.com. Project title: Dynamic Cluster Head Selection Method for Wireless Sensor Network. Let's see the abstract. Generally, a wireless sensor network consists of spatially distributed autonomous sensors. Most of the wireless sensor networks consist of static sensors which can be deployed in a wide environment for monitoring applications. While performing data transmission through multiple hops become less reliable. Wireless sensor networks consist of spatially distributed autonomous sensors to monitor the physical or environmental conditions such as temperature, sound, pressure, etc. and to comparatively pass their data through the network to a main location. The unbalanced energy consumption and overlap in coverage is becoming an essential task for providing dynamic clustering in wireless sensor network. In the view of wireless sensor network clustering algorithm at home and abroad, the dynamic cluster head selection methods for wireless sensor networks are put forward in order to solve the problem of unreasonable cluster head selection that may lead to the overlapping coverage and the unbalanced energy consumption in the cluster communication. Hence, the proposed system performs the reclustering process for all active nodes in the network. The quality of the topology control influences directly on the lifetime and the performance of the networks, while a good topology scheme relies on a complete evaluation methodology. The death of a cluster head node makes another redundant node active to be the cluster head. If the dead node is a current common node, another redundant node ends dormancy to be an ordinary node. It will efficient for the network which all nodes are split in a specific coverage area with the loss of information. The simulation results shows that the proposed scheme achieves better performance in terms of the delay and the coverage of the network. Let's see the flow diagram of our process. First, the network is formed with the number of sensors at the base station. Then the sensor nodes are forming clusters with the cluster members. After that, the cluster head is selected for each cluster in the network. This is done by the usage of dynamic clustering algorithm. After that, if the dead nodes are high in the cluster means it again redivides the cluster. The dead nodes may be the cluster head or a cluster member. If it is not done means it directly provides the transmission. And finally, the performance is evaluated for the proposed scheme which is compared with the existing system with the help of its parameters. Now we are going to see the output of our project. First, open the terminal window and go to the directory. Then type ns space filename dot tcl. Now the network animator window opens. Maximize the window. And these are all the number of nodes that created in the network. Run the simulation. Here a base station is created. These are the number of sensor nodes that are created within the transmission range. We can speed up the process. This is the simulation time that runs here. Now the clusters are formed dynamically in the network For each cluster, a cluster head is selected. Now the cluster head generates data and it forwards its data to the another cluster. So the communication process is between the cluster head only. It finds out the shortest path and it transfers data to the nearby cluster head. Now this cluster head forwards data to the another cluster head, and finally this data are transmitted to the base station. This specifies the dynamic clustering algorithm in the network. To see the performance results, back to the terminal window and type xgraph.delay.xg. So this is the delay graph that how much delay is occurred for a packet delivery. So how much time delay is occurred for each transmission of packets is plotted here. Then for another graph, type xgraph.thr.xg. This is the throughput graph here for each specific simulation time, how much maximum packets are transferred here or plotted. So this is the performance of the proposed system. Thanks for listening.